good morning, or afternoon, or evening. I don't know when you are watching this. Um, so, if you picked Ed Puzzle, then this is the only thing that you need to do for this week. This will be a longer video, but um, and then next week will be the last one, and it will be an Ed Puzzle 2, and then we're finished. The last week, June 8th through June 12th, that week is for makeup work. Um, we will have, I will post a video. I'm trying to think of something fun or funny or silly and we will have check-in times. I really, 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 really want you guys to try to come to a Zoom a few times, because if we are still doing distance learning in the fall, I want you to have practice, and to figure out what works and what doesn't work, because that will be new learning and that will be different. You won't be able to skip or ignore lessons like now. Okay, you're going to have to understand. Right now, we have been kind of flexible, and you're showing understanding, but it's been a little bit different. And in the fall, if we are still distance learning, you're going to need to be more attentive, I guess, is a good way to explain it. So, okay, without any more, let's go ahead and get started. We are still working on the Pythagorean theorem this week. So hopefully you remember what that is. All right, the first few slides are related to just some background review of the theorem, and then there are problems. So here we have 4 triangles, and I want you to study them, look at A, B, C, and D, and figure out which one doesn't belong, which one doesn't match the other 4, or the other 3, and explain it. Okay, so why is it that way? So take a minute, think, and then you'll answer the question. So there are a few ways to answer this, actually. Knowing that we have been talking about the Pythagorean theorem, we know that the Pythagorean theorem is related to right triangles, and we see that these triangles, of the 4 of them, there's 1, 2, 3. That shows that it's a right triangle. So you could say that B, this one, doesn't belong. Why? It doesn't have a right Okay, so that was one possible explanation. Another one could be that if you look at the hypotenuse, okay, remember the hypotenuse is the longest side. So if we look at that, there's that one, there's that one, and that one. So if you are looking at the hypotenuse, you could say that D doesn't match. Why? It doesn't have a square root, okay? We call that a radical. But this right here is just a whole number, okay? The other three have radicals. So those are two ways to have described. Maybe you found another way. So as long as your way makes sense and you can prove it with an explanation, then that's fine. This was just to get us thinking about triangles. So we are going to continue to focus on right triangles. This is another visual of knowing and having the Pythagorean theorem proved. So remember, the Pythagorean theorem says that the legs, when you square them and add them up, is the same thing as the hypotenuse squared. Okay, so here's our A squared, right? 1, 2, 3, 4. 4 squared is 16. Here's B. 1, 2, 3. 3 squared is 9. So this side is 3. This side is 4. And the hypotenuse is the sum, okay? The sum of those two sides. So that's how we, and if we were to count up all of the squares, the tiny ones inside that 25, and we matched up which parts kind of went together, we would find 25 squares also, okay? So all of these have the same type of situation, okay? Now remember, I want you to think about the different perfect squares, okay? We've talked about that throughout this year. So you'll see some of them here, right? Okay, 4 by 4 is a perfect square. Okay, 3 by 3 is a perfect square. Okay, look over here. 5 by 5 is a perfect square. Okay, but some of them are not. Okay, so if you were to take the square root of 9, you would get 3. If you took the square root, so if we did the square root of 16, you would have 4. But 18, you try, you see, what do you get if you do the square root of 18? It's not a whole number, okay? And that's fine. You're going to have decimals in this activity. So here's the next major question is, what is this? What is this value going to be? Okay, so remember, we did 16 plus 9, that's 25. 1 plus 16 got us to 17. 9 and 9 got us to 18. Okay, so I want you guys to figure out, because you can't count those squares up here. That's too hard. So I want you to use this and this, use those two, use a squared and b squared, figure out what is that c squared equal to. Okay, so what you should have done, right, is figured out how many are inside here. So we know there's 5 times 5, that's 25. And here is 3 times 3, which is 9. So we have 25 and 9. If we add those together, we get an answer of 34. So this, the answer should be 34. Okay? All right. So now we're going to shift to thinking about how we can use the Pythagorean theorem related to more real world situations. Okay? So here is our map of a very cute little town, but someone forgot to finish labeling all of the distances. So we're going to figure out what they are. All of the purple ones that are labeled A, B, C, D, E. For A, we're not going to need the Pythagorean theorem, but for the others we will. So I have to move me. Move me down here. Okay. So we know that just by looking at this, it's a rectangle. Okay. So we know that the distance from the church to the house, okay, right here, okay, we can find by adding 30 yards and 50 yards, okay? So we know that that whole distance is 80, okay? So that's 80. So, and we can see, look, there's 30 here and 30 here. So those chunks are the same, which means that from the school to the hospital, right here, and here to here, from the fire station to the house, those are the same. Okay? But we don't know this distance. So if we know that the whole thing should be 50 and this part is 25, what are we going to do to figure out the distance from the school to the library? Part A. All right. You think about it. You try to figure it out. I'm going to show it real quick over here. Okay. So this is a situation where we have the whole and a part, and we're looking for the other part. So if we have okay, this represents our whole, which we know is 50. We know part is 25. So what's that leftover part? Okay. And you'll always do whole minus part. So 50 minus 25. And that gets us to 25. So hopefully you found the answer to be 25 also. And you can think of 25s. Remember, we can count by 25s for quarters. 25, 25, 25, 50, 75, $1. So think about things in related to 25s. Okay, so now the next four are there's more work, more calculations that we're going to have to do in order to solve. They all involve the Pythagorean theorem. So here we go. Okay, so our map has a lot on it, okay? And if sometimes it's helpful to draw a separate triangle to help make the picture more clear for yourself. So, first things first, you need to identify what we're looking for, okay? So here, so there's the triangle, okay, that we're dealing with, okay, because we're looking for the distance from the school to the flower shop. So now that we have identified it, we want to pull it and have it separate and do our work on another paper. So you should have paper, okay, to work this out. So there's our triangle that we're working with, okay? So I want you to think, how are we going to set this up? We have a triangle, and its two legs have a distance, and the hypotenuse is what we're looking for. Okay? So what would be our first equation to have it set up? Okay? Think about, remember, a squared plus b squared equals c squared. That's what we're working with. Okay? So this should have been what you had, okay, for how to set it up. Okay, and we're going to review a little bit. We'll go through the steps together. Over again. Sorry, I'm moving all over the place. Remember, we are simplifying, okay? So we've set up the problem. We're solving for C, okay? So our next step is to go ahead and square those numbers. So 30 squared equals 900, and 25 squared equals 625. Okay? Next, what are we going to do? We're going to add them. Okay? So this has two kind of steps included. So the first thing that you should do is 900 plus 625. Okay? And that gets us to 1,525 equals c squared. Then we need to take the square root of both sides. Okay? Because remember, to undo something that is squared, we need the square root. And we have c squared. We need 1c. I don't want 2. I don't want c times c. I want c by itself. So we have to do the square root. What we do to the right, over here, what we do here, we have to do over here. So if we take the square root, that's what we get. 39.05. Okay? So now the question is, what does that 39.05 mean? Okay? Now that we have a number, we need to make sure we know what it's related to. So what does it mean? Okay? That 39.05 is the distance from the school to the flower shop. Okay? All right. Ready for the next one? Okay. So here's our next problem. We want to know the distance from the hospital to the vet office. Okay? Now, one of the questions we need to consider is making sure that we set it up correctly. Okay? So make sure that it gets set up, that the problem is set up the right way before you go ahead and solve it. So, when you get all done, okay, you should have had, right, we're going to do this one on the up here, so you can watch me walk through it. Okay, so we should have done 25 squared plus 15 squared equals c squared. Okay? $25 squared $625 plus 15 squared is 225 equals c squared. Add these two together, we get 850. Oops. Equals c squared. And then what do we do now? Square root, square root. There's our answer. Okay. Okay, so we've now done 2 problems, okay, where we knew the legs and we had to find the hypotenuse. Okay, this problem is different. Okay, so again, make sure you find the triangle that we're working with. Okay, so here, okay, we want to know the distance between the bakery and the museum. So that's this one up here. So you have to find the triangle that matches up with it. So we're going to go this triangle right here. Okay. Now this one, okay, setting it up, okay, it's not going to set up the same way as our other ones. How are you going to set it up? What's it going to look like? What will it, the a squared plus b squared equals c squared. What numbers are you going to put in? Okay, this is what you should have. Okay, because we don't know that one side. You could have a squared equals 45 squared. I'm sorry. A squared plus 45 squared equals 60 squared. That's fine too. The A and B, that doesn't matter. Okay, so we should be here. Okay, so now go ahead, try to solve this, find our answer. What is the distance between the museum and the bakery? Okay, so you should have taken time to solve that. Now let's see how you did, and if you got it right, great. If you made a mistake, let's see where that might have happened. Okay, so first things first, we need to go ahead and square those numbers and get our numbers. So, okay, now we have a 2-step problem. Okay, and remember, the first thing with 2 steps is that we want to take care of the addition and subtraction first. So, and our goal is always to get the variable, in this case b, alone. So right now, with b, right here, this little guy, 2025, is with b. So we need to get rid of it. Okay, so what do we do? Okay, we have to subtract 2025 from both sides. Okay, and that will leave us with b squared, because that simplifies to 0. So this is where we end up, is b squared equals 1,575. Now we need to take the square root. Okay, and that's our answer. When we do 1,575, take the square root, it's 39.68. So again, what does that 39.68 mean? What's that number for? Okay, it's the distance between the museum and the bakery. Okay. All right. So We're going to keep right on going. We got one more problem to work out. Now, this one, we have the legs, okay? But this one, it's a little bit more visually complicated. So, the question on hand is, what is the distance from the cinema, okay, the movie theater, the cinema, to the fire station? Okay? So, I want you're going to stop now and you're going to work that out, okay, yourself. Remember to draw a new triangle, label everything, and then work your way through the whole problem, and let's see if you get to the same answer as me, okay? Our legs, 20 squared plus 50 squared equals c squared. Go ahead and square them. 400 plus 2500 equals c squared. Add them up. 2900 equals c squared. Take the square root. 5385 equals c. So, again, what does the 5385 mean? That number is what? What was our question? Okay, so that is just one of the ways that we use, okay, Pythagorean theorem to solve kind of real world problems. Now on the next slide, we have 3 different word problems, okay? We're not going to solve them, but I do want you to try to draw a picture that matches them, and then see if your picture is right. So we're going to read through the problems together, and I'll think about it kind of out loud a little bit, and then you guys will try to draw the pictures. You don't need to send them to me. This is just for yourself, and then we'll look at what the pictures look like. So, oh, just kidding. So here's another way, okay, to think about solving, okay, and we can do this another time, but this is just another way to think about finding either the hypotenuse or a leg. Okay? All right, here are the problems. So, the first one says, the school, park, and movie theater form a right triangle when shown on a map. So this is exactly the same idea as before, except now we don't have the picture. Okay? The longest distance is between the school and the park. If there are 3.4 miles between the school and the movie theater, and 5 miles between the park and the movie theater, how far is the school from the park? Okay, so we just did maps, okay? So be thinking about how to draw that up. The important part here is right here. This is what's going to really help you know how to set up that triangle. The longest part is between the school and the park. So think about On a triangle, on a right triangle, which side is the longest? Okay, so that's the first one. So you're going to try to draw that. The second problem, Brandon is making a ramp. Okay, the ramp is 3 feet tall and 9 feet long. How long is the base of the ramp? So think about like a handicap ramp going into a building, or a ramp that you might use for, well, like a kid might use for um, skateboarding or something. So that's what we're thinking about. So try to picture that and then draw that. It's 3 feet tall and it's 9 feet long. Okay, last one. Last one. Andrew needs a ladder to hang up some holiday lights. His house is 24 feet tall, and he has a flower bed that is 4 feet out from the side of the house. So, how long does the ladder need to be to reach the top of the house and not be in the flower bed? Okay, so again, picture a house. Okay, the flowers are on the ground, right? And they're growing, they're near the house. What's that distance? Okay, so the house is this tall, and those flowers are down here, and the flowers come out from the house. Okay, so think about like mulch with the flowers are growing, they come out. So and the ladder, where's the ladder going to go? Okay, so you're going to take a few moments and draw those pictures, and then when you're done, we'll keep going. Okay. So, okay, so here are the 3 pictures. There's our map. Remember, I told you the important part was the longest distance was the school to the park. Okay. That's the hypotenuse. So that helps you know how to draw the rest of the pictures. Okay. The ramp. Okay. So if you think about, if you were to picture what a ramp looks like, the long part, okay, that's the actual ramp that you're using. If you're going up it, the tall part, okay, that's how high it comes off the ground. So what's that base going to be? So that's the base down here. All right, and there's our third picture. Okay, our house. You like my flowers? You like my flowers? And then this would be the ladder. Okay. So, again, these are 3 examples of how we would use Pythagorean theorem in the real world. And this one's important because ladders of different lengths obviously cost a different amount of money. So you don't want to buy a ladder that is like huge if you don't need it, and spend that money. If you are building a store or a house, or if you are renovating, um, especially if you are in like business, knowing how to, knowing that you need to have ramps for handicap or um, for ease for deliveries. Okay, this is where we would see that used in engineering. Okay, so that wraps up Pythagorean theorem. Um, make sure you answer all. You can't skip this, so hopefully I will see you Thursday. We might go ahead and solve these 3 problems on Thursday, and just chat. So, okay.